Good morning, grade 11th. We are going to look at solutions to trig equations. Okay, when we solve trig equations, we are looking for the value of theta that makes the right hand side true. Okay, I have an example here. This is what we are going to be dealing with, more or less. Okay, so what we are saying here is that we want the theta to stand alone, or we want to find a value of theta here that is going to ensure that when you put this with the sign in your calculator, you will get a half. Okay, before we solve for the equations and for theta, we need to work with the 4 quadrants. So let's just do a quick recap on the 4 quadrants. We've got quadrant 1, which represents MR values that are between 0 and 90. And then we've got quadrant 2 for values that are between 90 and 180. Quadrant 3 for values between 180 and 270. And then quadrant 4 for values that are between 270 and 360. Okay, so how do we then work out the values in each quadrant? I just did separate diagrams for each quadrant. Okay, quadrant 1 is theta. Now you'll notice that I did theta here, and then by reflection this theta is the same as this one, and then again by reflection along the x-axis this theta is the same as that one, and again this theta is the same as that one. So that means to find a value that is in the second quadrant, let's look at this one which is more clear. If this is theta here and the whole line is 180 degrees, it means if I'm looking for this one that is marked in blue, this angle here, which is an obtuse angle, I would have to say 180 minus theta. So that is why my angles that are in the second quadrant will be calculated like this. And now you'll see that this theta that I'm talking about is the one that is in the first quadrant. Now we just reflected it to the second quadrant, but that's how we find the angle in the second quadrant. Now how do you find angles in the third quadrant? Third quadrant, again, I have separated the diagram so that it is clear for you. Now this whole line is 180 degrees, you see, and then we've got theta already here. So if I want the whole angle from here all the way to there, it's then going to be 180 plus theta. So that is why we are saying the angles here are 180 plus theta on the third quadrant. And then on the fourth quadrant, which is this one, quadrant 4, this one, which is the fourth quadrant, okay, quadrant 4, the whole revolution here, the whole revolution is 360 degrees. So if I've got this portion here and I'm looking for only this reflex angle here, then it's going to be what? It's going to be 360 minus theta. So that is why my angles that are on the fourth quadrant are calculated like this. So it is very, very important that you remember these calculations. Here it's theta, which is an acute angle that is between 0 and 90. And then second quadrant, the values are calculated by 180 minus theta. And then here we calculate using 180 plus theta, and then here is 360 minus theta. So it's very important that you remember this, because that is what we make use of when we solve the equations. Okay, so that's what I was saying over here. There will be more than one answer to each question. Now why is that? You'll see that in the example that I started with, where we have the sign, if you see the fraction this side is positive, so that means the answer that will give me a positive half will either be in the first quadrant because sign is positive here, or the angle will also be in the second quadrant. It will be in the second quadrant because again sign is positive there. So whenever you solve an equation, you have to find first the place where the fraction or the decimal is going to be positive or negative at. Okay, so that is what I did over here. Okay, so depending on the restriction, you'll have more than one answer. So let's look at the first example. We've got tan theta, which is equals to 2. Now 2 is positive. Then you check in your quadrants. Tan is positive in the first quadrant and it is also positive in the third quadrant. So that means I'll find an acute angle as well as an angle that is between 180 and 270. Okay, so that's what I do. Now, how do I find theta? It's like you're solving an equation of your 2x equals to 4, where we want theta to stand alone. So it's like you're dividing by tan on both sides, but we don't have this function in the calculator. Now, if you remember your exponential, your exponents, if I have 1 over a, I can write it as a to the power negative 1. So we use that here, and then this 1 over tan will then be tan inverse, or tan to the power negative 1. So that is what we use when we solve an equation. It's an inverse. We're going backwards to find the theta. That's why we use tan inverse. And then this is how you press shift and then tan, then it will give you something like that. And we don't write it like this. I was just showing you why we have a case like that. Okay, so we are looking for theta. Then I've found the two places is quadrant 1 and quadrant 3. Okay, so we then you do your tan inverse and then you find that the angle is going to be 63.43. Okay, and then now because we have two answers, the third one on the third quadrant, so theta number 3 is then going to be 180 plus theta 1, so which is the angle that we found in the first quadrant. Then you say 180 plus 63.43, which then gives you 243. So that means if I put this in my calculator, it's going to give me 2. Let's just check. This is my calculator. Okay, tan, and then I put 63.43, 63.43, and then close. If you press equal, you'll see that okay, sorry for that, tan 63.43. okay, if you press equal, it will give you 1.9995, which when you round off will give you 2. And then if you put 243 in your calculator and you press equal, it gives you the same value, 1.9995, which then shows you that the right hand side is indeed true if we use these two values of theta. So basically that's what we are doing. Round off to 2 decimal places unless the question states otherwise. So all the time your answers must be rounded off to 2 decimal places. Okay, and then I've got more examples. Okay, by second one, we've got sine, which is equals to negative 0.56. Now, sine is negative according to the 4 quadrants. Sine is negative on the third quadrant and on the fourth quadrant. Now, third quadrant, we said the values is 180 plus theta, and the theta that we are referring to is a theta that is in the first quadrant. Okay, now if you calculate just normally, where you find sine inverse of negative 0.56, we get negative 34.06, which is now wrong. Well, not wrong, but it is not within the given restriction. So that tells us that we need to find an angle that is in the first quadrant so that we can be able to do these calculations, the 180 plus theta and the 360 minus theta, which is in this theta is the theta that is in the first quadrant, not a negative one. So that theta we call a reference angle, theta 1. Okay, so remember all trig ratios are positive in the first quadrant. So it means that if you are looking for an angle that is in the first quadrant, we cannot use negative. So we drop the negative here so that we can find our reference angle. And then it becomes 0.56. And we are dropping it because we are looking for an angle in the first quadrant. And in the first quadrant, none of the trig functions are negative. So that is why we drop the negative. So when you drop the negative, you'll see that you get a nice acute angle, which is positive. Then this is the one that is then going to give you your two answers, which are on the third quadrant and the fourth quadrant. So it is important that you do this analysis before you can answer your question, so that it will tell you where you must find your answers. Okay, so that's what I did. Okay, and then I've written here, ensure the angle that you add or subtract to find your answer in the four quadrants must be an acute angle, which is in the first quadrant. Please remember that. Okay, so here you'll see that the trig function is not isolated. So the first thing that we'll do is we'll divide by 3 on both sides. Please remember that this is one term. So when you divide by 3, you're not going to divide the theta. So it is divide by 3 here, divide by 3 there, and then you've got cos theta, which is equals to negative 2 over 3. And then cos is negative on the second quadrant and the third quadrant, where we use 180 minus theta and 180 plus theta, and that theta must be in the first quadrant. So that tells you, Guti, we need to find theta 1. So theta 1, our reference angle, is then going to be cos inverse of positive. So we drop this because in the first quadrant we don't have any negatives. Okay, so we drop the negative, so it gives us an acute angle, which is 48.19. Okay, and then we find our answers. The two answers are then going to be 180 minus that, which gives us 131.81, and 180 plus that, which gives us 228.19 degrees. Okay, so whenever there's a negative, the first step is to find the reference theta, which is in the first quadrant, before you can find the actual answers that you are looking for. Okay, and then we have the last example, which is this. Again, as you can see, the sine theta has not been isolated. So the first thing is to take the 3 to the other side. Then we've got 3 there, and then we divide by 4 both sides so that we can isolate the trig function. So whenever you're solving an equation, this must be isolated, okay, so that we can be able to decide where it stands. Okay, 3 over 4 is positive, so the answer will be in the first quadrant and on the second quadrant. Okay, now there's no need for us to find, because this is positive, there's no need for us to find reference first. We just go straight to quadrant 1 and we find that the answer is 48.59, which is our reference angle. Okay, and then theta number 2 is then going to be 180 minus theta number 1, which is 131.41. Okay, so I hope the examples are clear. Please do exercise 10 on page 161 BF number 2, and then you do yellow page. I'll send the picture and then you do these. Thank you.